Good afternoon. This is Lili, Associate Professor from UFTI. It's my great pleasure to share our recent study with you. The presentation is titled as Data-Driven Approach for First Last Mile Gaps and Hybrid Transit Services. Through this project, we want to help cooperate transit with on-demand mobility services to improve transit ridership and mitigate traffic congestion. More exactly, we use the picture on the right to show our motivation. We noticed that the advance of communication and information technologies have enabled several emerging on-demand mobility services, including car sharing, bike sharing, microtransit, and so on. Those emerging modes provide convenient and flexible services, but they usually are with small capacity and will potentially introduce extra traffic and make our congestion and emission worse. On the other hand, transit is more sustainable, but cannot fully satisfy mobility needs due to its fixed schedule and routes. Transit users often suffer from the first and the last mile gaps. Therefore, one promising solution to address this problem is to cooperate the transit with these emerging mobility services so that we can take advantages of both types of mobility services. However, this is not an easy job, as the picture shows that people have recognized TNC, microtransit, and micromobility can be potential used in transit low-density areas for ad hoc demands or to complete the trips at transit first and last mile gaps. But the state of the art shows that transit planners have insufficient or limited information on where and when we should link transit with on-demand mobility services to obtain the best performance. This project would provide an innovative data-driven approach to address these challenges. Our approach is to co-analyze transit and on-demand mobility service trajectory, and then use machine learning approach to identify those potential critical areas which are proper candidate locations for cooperating transit routes and on-demand mobility services. The idea behind this approach is that we notice existing on-demand mobility services are highly correlated with transit services. Mainly, those areas lacking sufficient transit coverage and flexibility will more likely the market that attract more on-demand mobility trips. Accordingly, investigating their trajectory data over a city network will help reveal interaction between those two types of mobility services and further identify the good candidate areas to cooperate them. To implement our approach, we use trajectory data as input, including transit bus trajectory data and the trajectory data collected from other modes, such as vehicle GPS data of ride-sharing vehicles, bike, and private autos. Those trajectory data will be aggregated and graded by our optimization model and further processed by our algorithm to generate heat maps. Then we use machine learning approach to find those critical zones with interesting patterns on the heat map. Those zones info potential critical areas for cooperating transit with other modes in the physical map, such as the first and the last mile gap. The future transportation system will be connected and multimodal. It will involve both public transit and private vehicle services, providing regular service with fixed schedules and irregular service, such as on-demand services. Our product contribute a data-driven method to find when and where the transit should cooperate with on-demand mobility services. It can potentially help transit increase ridership and ultimately help mitigate the traffic congestion and reduce emission. With this is come to the end of my presentation. Thank you very much for your attention. If you have any questions, please feel free to contact me by the email on the slide.